Hi there, this is Professor Eckhouse, and I'm going to be talking about the first section in pre-algebra for college level students called Whole Number Basics. So there are some things in here which I'm sure you know and some things you may not remember, especially some of the vocabulary. So try to stick it out to the end if you can. You may learn something. So you're going to learn here, and this is always going to be at the top. This is basically the objectives of the lesson, of the things I'm going to be covering. If it's in green, I'm not going to talk about it. It's in our book, and you can go take a look. There's lots of resources on learning how to use base 10 blocks. So that is not going to be the focus of this course, but it might help you to understand base 10 numbers and then even maybe understand other bases like base 2. All right, so first we just need to know some terminology. What do we mean by counting numbers? Those are just what we often consider whole numbers, 1, 2, 3, 4, 5, but they don't include 0. So they start at 1. The whole numbers start at 0, 0, 1, 2, 3, 4, 5. So the counting numbers and the whole numbers are both almost exactly the same. I have a bird outside the window here, sorry. Except the whole numbers include 0. So the first example asks us which of the following are counting numbers. So the counting numbers are not going to include 0, and they're going to be the whole numbers. So we'll just start with the 3, and the 5.2 and the 1/4 are not going to be included in either one. So I'm going to cross those out. Just makes it easier to look at the list because I know they're not either one. And 15 and 105. All right, then the whole numbers are going to be the same, except including that 0 that's listed there. 0, 3, 15, and 105. Okay, so like I said, using base 10 blocks to understand the base 10 number system and digits. Please do see the book. There's some great try-it problems, and there's some good videos within the book that will teach you how to use base 10 blocks and to understand the base 10 number system. But we're going to jump right into identifying the place values of a digit, which you need to know how to do for this course. So we're going to start with this number given right here. Okay, so we're going to start with that, and so we've got a chart here. So we've got billions, millions, thousands, and ones, and then there's a dot over here at the end. Okay, with these commas in between each three place values. Okay, so all of those things help us to look at the number easier. That's why we use the commas. The commas also help us to name it, which we'll talk about here in just a second. So if we take this, if you just start at the right, I guess, if you are confused by this, just start with the right digit and work left. 5, 2, and 0, that's the 0, 2, 5 at the end. And then we've got the 3, the 7, and the 8, and the 4. Okay, so now we can tell what digit what place value each digit holds. Okay. So we've got the 4 here. The 4 right here is going to be the millions place. The 8 is the 100,000s place. The 7 is the 10,000s place. The 3 is the 1,000s place. This seems so simple, but lots of times we've never even thought about this. So it's good to know because you need to know how to name these and figure out what place value everything is in. Okay, so if we look down at example 2, they're asking us to find the place value of each of the following digits. It might be easier to not make a mistake if you use the chart. So you can just find a simple chart. You can use the one here in the template if you're in my class and have access to this OneNote. So we've got 63,407,218, and we want to know what place value the 7 is in. And that is in the 1,000s, or you can just say thousands. I'm fine with thousands. Okay, so don't say thousandths, because that would be over here in the decimals, which we haven't gotten to yet. We'll get to that. Okay, and then we've got the 0. What place value is the 0 in right here? That is in the 10,000s. Ooh, I'm going to write out 10, actually. So we're going to say 10,000s. Place. What place value is the 1 in? The 1 is here, and that is in the tens place. What is the 6 in? The 6 is right here, and that is in the 10 millions place. So we're going to say 10 millions. And the 3, let's see, what color should I use? The 3 is right here, and that is in the 1 millions place. Okay? Got a little skinnier. All right. So that's how you do that. You don't have to use the chart. If you can look at the number and figure out which place value it is, that's fine. So I just wanted to show you this. This is what the try-it problems in the book look like. They look exactly like the problems in the homework. So I highly recommend that you use these and use the book. So there's also going to be videos. So you'll see an example and with the answer, and I used a lot of the examples in my lecture. So the examples have written out problems, and then there is a new example in the video with a different problem. And so you can watch those videos to see more examples. And as the class gets harder, that may be helpful to you. All right, so now we're going to use place value to name whole numbers. So 37 is in the millions place. So we've got these three different sections. That's too dark. Let me undo that. 3 different sections here that have the different place values. So each of those is called a period. Okay, so each 3 sets of numbers, this set of 3 numbers, I should say, is a period. So we've got the ones, the thousands, the millions. So if we go up here and look back at our chart, each of these is a period. The billions period, the millions period, the thousands, and the ones. Okay, so come back down and take a look at how to name things. So we're going to use all of the periods in the name, the millions, the thousands, the billions, the trillions, except for the ones. We don't say 248 ones. So this number here looks like 37 million, because it's in the millions place, 519,000. Notice I didn't say and. So we don't put ands everywhere. We just leave out the ands. I know at some point we were taught that, but now we just leave out the ands because it just makes it easier. 519,000, because it's in the thousands place. 248, we don't say 248 ones. We just say 248. Okay, and we don't say and. So here's an actual set of steps if you like to use steps. So make sure you're using commas to separate things. So this I'm probably not going to write out, but I'm going to say it. So you can repeat it if you need to, just rewind and listen. So this is in the billions, the millions, the thousands, and the ones. So this is 7,843,565,129. Notice I did not say and anywhere. I'll say it again. 7,843,565,129. 129. I almost said and, but you don't need it. Okay? All right, so use place value to write whole numbers. Identify the words that indicate the periods. Okay? And then draw 3 blanks. So we're going to go the other way now. We're going to draw 3 blanks between the commas to indicate the number of places needed so you don't miss anything. And then name the number in each period and place the digits in the correct place value. So this is just doing what we just did completely backwards. Okay? So I'm going to try to give us a little more space here. So the first one, 53,401,401,000. What is this? Well, think about that. What's missing there? There's going to be a 0. 742. Okay, so let's start with the 53 million. So we're going to have 3, and then I'll use a different color, and then I'll use another different color. Okay, so let's start with the millions place. Okay, so that's the purple. So we've got 53 million. All right, so we're not going to have anything in the hundreds place there. It's just 53 million. Then there's 401,000. Now remember, we don't use ands. So 401, what is that? Well, that's 401, like that. And then 742, 742. So there's our number. All right, so pause the video and try the second one. All right, so I'm putting my lines in, and I'm going to go up and think about each of these. So 9 billion. we need billions. Oh, I missed that. Okay, let's go and add billions. So let's see, orange. So we've got billions there. Okay, so we've got 9 billion. That's our 9 billion. 246 million. 246, that's our millions, period. And then we've got 73,000. So there's no hundreds place in that. There's no word hundred. So there's going to be 0 and 73. And then the 189 looks like that. Okay, so 9 billion, 246 million, 73,189. So it checks. So I would definitely go back and check those, make sure they make sense. Okay, so rounding whole numbers. This is challenging for most people and who don't really understand why we round or what we're really doing, and the rules don't make sense. So I'm going to show you on a number line. Rounding is basically telling us what number a given number is closest to, okay? What number a given number is closest to. So let's think about what's happening here. And we're going to think round 76 to the nearest 10. So what that means is it closer to 70 or 80? So you've got to know your place values from what we just did before. So one thing leads to another in math. So what we just did is important to be able to round. If you don't know your place values, you're not going to be able to round. So make sure you know your place values. Round 76 to the nearest 10 means, is it closer to the tens place of 70 or the tens place of 80? So here's our number line, and you can see that 75, of course, is right here in the middle. So 76 is going to round to 80. It's closer to 80 than it is to 70. So it rounds to 80. Okay? All right, 72. Which one is it closer to? If we're going to round to 70 or 80. In other words, round to the tens place. Okay, round to the tens place. So if 75 is in the middle, then it rounds to 70. So it's going to round to 70. I don't say equals. I don't use the equal symbol. Okay, I say it's going to round to 70. I use an arrow or colon or something. Don't say equals because it doesn't equal 70. It rounds to 70. It's closer to 70 than it is 80. So what do we do about 75 when it is right in the middle? Well, the rule that we use is we round it up. We had to decide one way or the other, right? So we round it up. And when you get really technical about it and you look at which one it's closer to, it is, so if it's exactly 75, I'm just not going to go there. If it's exactly 75, we're just going to use the rule that it rounds to 80. Okay. I think I will move on. So round a whole number to a specific place. Locate the given place value. Underline the digit to the right of the given place value. So we're going to go to the place value to the right of the given one and determine if that digit is equal to or greater than 5. If so, we're going to go up. If not, we're going to leave it the way it is. Then we're going to replace everything to the right with zeros. So let's think about what this is going to look like. Round 275,473 to the nearest 10. So I'm going to rewrite this. 275,473 to the nearest 10. Okay, so we've got the tens place is right here, right? And we want to know what the 3 is going to do to it. What is the 3 going to do to it? So the 3 is not going to round it up. It's going to leave it at 70. It's closer to 70 than 80. Okay, so we're going to say 275, 470. Okay, so it rounds to 275,470. All right, so let's do that again. This time, 275, 473 is going to round to the nearest 100. So the hundreds place is right here, and this is the digit we want to look at. Is it going to go up or down? Well, it's going to go up. Okay, so this becomes 275. Now, we've got to think about what's going to happen to the 4. Does it stay a 4 or does it become a 5? In other words, is it closer to 400 or 500? It's closer to 500. So this is going to become 275,500. All right, the next one, we are going to look at thousands. 275, 473, and we're going to look at the thousands place. So that is this place value here. So we want to know what this digit is going to do to it. So it's less than 5, so it's not going to round it up. It's going to leave it a 5. So this is going to be 275,000. All right, the next one, you try it. Why don't you pause the video and try the next two. See what you can do with these. Okay, hopefully you paused and you gave it a try. So I'm going to write it every time. And let's see what happens. We've got 10 thousandths place. That's this place value right here. So we want to know what the 5 is going to do to that place value. And the 5, we have decided, rounds it up. So this is going to become 280,000. So 280,000. In other words, is it closer to 270,000 or 280,000? And it's closer to 280,000. All right. The next one is to the 100,000. So let's point at the 100,000 and we'll say, what is the next digit? It's a 7, so it's going to be closer to 300,000. So in other words, is it closer to 200,000 or 300,000? Because that's the place value they're asking us to round to, and it is closer to 300,000. Okay, so these take practice. Math involves a lot of rounding, especially applied problems, because you just need to know what to round to if you're dealing with money or anything like that. All right, so try this one. Pause the video and give it a try, because it is tricky. Okay, so hopefully you gave that a try. So we're going to have 6,993. And we're going to round it first to the nearest 1,000. Okay, so that's that's how I used to do it. This is my new way. I'm going to point at it to the nearest 1,000. So we want to know what this 9 does to it. Well, of course, it's going to round it up to a 7. So this becomes 7,000. So now here's the tricky thing. The rounding it to the nearest 100. So to there. So what is this 9 going to do to the next 9? Well, it's going to round it up to a 10. So there's a couple different ways to think about this. It's going to round it up to a 10, and if you think about the addition algorithm that hopefully you know from elementary school, that 1 carries over to the 6 and it becomes a 7. So strangely, this also rounds to 7,000. If you think about it on a number line between 6,900 and 7,000, what is it closer to? Well, it's over here. It's definitely closer to 7,000. Actually, it's probably even closer. It's probably more like here, right? Because this is 6,950, right? So it's definitely closer to 7,000. So either way that you look at it, number line or carrying digits, you get 7,000. All right, so a little tip, use the summary section in the book if you're in my class to see a nice summary of all the topics and the vocabulary for every single section of every single module in the textbook. And you will be responsible for knowing the vocabulary, whether I go over it in depth or not, because it's in the textbook. Okay, thanks for watching.